Hello, what I have for you right now is a problem I like to call afraid to walk alone. And it is based on some data that was actually published in Time magazine a few years ago. And what they did was they published the results of a survey. And the survey they took in New York City, and they asked 300 people, are you afraid to walk alone at night? And of the 300 people, 132 said, yes, I am afraid to walk alone at night. Now, from this yes, they noticed that this was a binomial distribution because you either are or are not afraid to walk alone at night. So they could turn this into an SP, or sample proportion, of 132 over 300, which turns out to be 0.44. So we have 44% of the people from this survey saying that they're afraid to walk alone at night in New York City. Now, a newspaper reporter wants to borrow this data and say, gosh, can I run a headline that says, half the people in New York City are afraid to walk alone at night? You go, I don't know. Let's find out. In order to find out, what I want to do is I want to take this binomial and do a hypothesis test to see if the truth could indeed be a half. Or in other words, my null hypothesis is, could the truth, remember, I've got a Greek letter, Greek letters mean truth, could the truth be a half, or 0.5? My alternative is simply going to be that it is not a half. So I've got a binomial hypothesis test. This is my null and alternative hypothesis. I've got my sample data here of 0.44 for my sample proportion and n of 300. All right, so what I'm going to do is I'm going to calculate a test statistic. Well, you've probably seen a few of these, but my test statistic is just going to be my SP minus my null over the square root of my null times 1 minus my null over n. All right, so this turns out to be my sample proportion of 0.44 minus 0.5 over the square root of 0.5 times 1 minus 0.5 over n, which is 300. That gives me a test statistic of negative 2.07. All right, so what does that tell us? Well, what it tells us is based on my acceptance rejection region for this problem. Now, what I'm going to do here is say, oh, all right, let's do again 95% because we're all pretty happy with that by now. So I want 95% confidence. That means my significance level is 5%. My cutoff values are 1.96 minus 1.96. So this tells me my accept versus rejection region. So I accept if it falls in here, reject if it falls out there. What I'm accepting or rejecting, again, just to remind you, is this null hypothesis. All right, so now I have a negative number. What do I do with that? Well, I look to see where it fits down here. Well, negative 2.07 is to the left of negative 1.96, so it falls out here. That means I'm going to reject the null. Rejecting the null means that it is not a half. If it's not a half, what is it? Go back to the sample data. Truth is likely to be closer to this sample than it is to a half. So no, your local newspaper can't say more than half the people are afraid to walk alone at night. Well, that didn't lead to a very exciting headline. So what your people did at the newspaper was they said, well, okay, then I won't go with that headline, but how about I look at some other data they found. And the other data that was published in this article was based from a survey in Milwaukee. And in Milwaukee, they asked 300 people the same question. Are you afraid to walk alone at night? Well, in Milwaukee, they only had 99 people say yes. Or in other words, the sample proportion from Milwaukee is 0.33. So the question becomes now that your newspaper people are saying, well, okay, I can't say, you know, more than half the people are afraid to walk alone in New York City. Can I at least say it's scarier in New York City than Milwaukee? You go, let's find out. To do that, what I need is I'm still going to do a hypothesis test, but now it's a binomial two-sample hypothesis test. So I'm going to change this from a one-sample test to a two-sample test. Because again, what I'm doing now is I'm going to compare two surveys. Since I'm comparing two surveys, that means what I have is based on a null hypothesis that's going to look different. My null hypothesis is not going to be a single point. Instead, it's going to be the difference. So it's going to be what I'll call SP1 minus SP2, or I guess technically I should write this as the truth in group 1 minus the truth in group 2. Does it equal 0? So it's really cleaner if I do. That is my null hypothesis. Sorry. So, are they equal? And my alternative is that they are not. Now, okay, this is what I want to know. I haven't yet decided who is group 1 and who's group 2. The way to do this is to think ahead a little bit and assign group 1 the one with the larger SP. And the reason I'm doing that is because then when I take the difference, I have a positive number. So New York City is going to be group 1. Milwaukee is going to be group 2. Now, when I do this, I have to find what's called an SP pool. SP pool is the pooled sample proportion. And the SP pool is going to be 300, or in other words, the sample size from group 1 times the SP of group 1, plus the sample size of group 2 times the SP of group 2, over the total of both surveys. Essentially what this is taking all the yeses from everybody, because 300 times the 0.44 gets you back to this yes of 132. And adding the 32, and then what this becomes is the 99, and finding the average sample proportion. Well, the average of the sample proportion here is 0.385. Okay, I'll take a little note here for you. Note, when you're doing this, the number you get here had jolly well better end up between these two SPs. If it doesn't, you messed up. So I'm just saying, at this point, look at your SP pool in these type of problems and make sure you end up between these two numbers. Because if you don't have an average. It means your math just got messed up somewhere. So there's my SP pool. All right, so let's do this two-sample binomial hypothesis test. All right, so again, I'm going to find my test statistic. My test statistic is going to be the difference of the two SPs, or SP1 minus SP2, plus or minus the critical value. Again, we might as well go with the same 1.96 from 95% confidence, just because we're sort of used to it. But now what I'm going to do here is, I'm sorry, I did that wrong. I screwed that up. There are different ways of doing test statistics. This one's better. My test statistic is SP1 minus SP2 divided by this standard error based on my SP pool. So it's 0.385 times 1 minus 0.385 times 1 over 300 plus 1 over 300. I will note the square root sign goes over the whole thing. I then end up with a test statistic of 2.768. Notice, because of the way I picked group 1 and group 2, that I end up with a positive test statistic. And I don't know about you, but I like positive numbers better than negative numbers. So Now that I have calculated this, I decide on my accept versus rejection region. And these start looking pretty familiar by now. You've got accept here. You've got reject, reject. Okay, so I've got 1.96 minus 1.96. And my test statistic of 2.7 is way out in the rejection region. So again, I reject the null. What does that mean? Well, what I'm rejecting is this null hypothesis right here. That means that the truth behind this, the true proportion in group 1 minus the true proportion in group 2, is very unlikely to be 0. I say very unlikely because this is a 95% confidence interval, a confidence level, which means 5% of the time I could be making a mistake. We are not perfect. We don't know exactly the underlying truth, and we're never going to know. So the best we can do is make a really good guess. Well, we are going to be right 95% of the time, which I think is a pretty good guess. So 95% of the time, we're pretty sure they're not the same. Okay, if they're not the same, what are they? And this is where I look at the SP1 minus SP2. Well, SP1 is the 0.44. I subtract SP2 of 0.33. Notice that that gives me a positive number, 0.11. In other words, SP1 is bigger than SP2. That tells me that the true proportion in group 1 is larger than the true proportion in group 2. In other words, New York City is scarier. And that is how you do binomial hypothesis testing and two-sample binomial hypothesis testing. And it's scarier in New York City, according to this data. Okay, thank you for your time.